In this video, we will cover another proof of Pythagorean theorem. In an earlier video, I showed one proof. So this is the second proof for the Pythagorean theorem. And what is the Pythagorean theorem? If you have a right triangle with legs AB and hypotenuse C, then a square plus b square is equal to c square. Now for this proof, I'll use this idea. What is the idea? The idea is if you have two right triangles, it does not matter what size they are, but so let's say I have one smaller right triangle and another big right triangle, and it is also rotated. But if one of the acute angles matches, then these two triangles will be congruent. So if I call this as ABC, and let's write this as D, this as E, and this as F. Now, if these two angles match, notice that this is angle A is the complement of C, and angle D is the complement of F. So A and D will also match. So triangle ABC will be similar to triangle A corresponds to D, and B corresponds to E, and C corresponds to F. So triangle ABC will be similar to triangle DEF. So they are not congruent, but they are similar. Okay, this is the idea we are going to use. And let's go ahead and prove Pythagorean theorem using this idea. So what I'm going to do is draw a right triangle and label the legs with AB. So this is a right angle, but I'm not going to write that because I'm not going to draw because I intend to split it. Now, let's also label the vertices. If this is A, then I got to label this opposite vertex with uppercase A. If this side length is B, then this is B, and then this is triangle ABC. And also notice that the hypotenuse is C, but I'm not writing even that because I intend to drop a perpendicular that would split the hypotenuse. So let's go ahead and drop a perpendicular from C onto AB. So if you do that, then this is what you get. Now in the original triangle ABC, let's use a single arc for angle A and double arc for angle B. Now C is a right angle, but we are not showing that because that got split into two parts. And notice, and let's also label this point as D. So from one big right triangle, we actually obtained two smaller right triangles. BCD is a right triangle and CDA is another right triangle. Now, moreover, if BCD is a right triangle with angle B written with double arc, then this angle must be angle A because the complement of this double arc is the single arc. So in this right triangle, the angle C or angle BCD is a complement of angle B. So I'm going to use a single arc for that. Now similarly, this is a right angle, and So angle DCA should be complement of the single arc. So that has to be double arc. So what we have is three right triangles that are all similar to each other, because you have a right angle and then you have these two angles, a single arc and double arc. All right, so now we can use the ratios of corresponding sides. Oh, by the way, let's call this part BD as X and AD as Y. And X plus Y is equal to C. All right, so now we can write down, we can say this. The smaller triangle BCD, this is similar to the big triangle, but I got to be careful with the labels. How do I write the original triangle? B corresponds to B, but C is the single arc, so that corresponds to A, and D was the right angle, so here this is going to be C. Which means I can write down the ratio of BD. So BD is the first and third letters over BC, the first and second letters. So this is going to be the first and third here is BC over the first and second are BA. And those of you who know trigonometry, you can see this as the cosine of this double arc, x over a. And if you look at the cosine of this double arc in the big triangle, that's going to be that BC over AB. So in other words, let's write down BD is x, BC is a, is equal to a over BA. BA is x plus y. So from here, we can cross multiply and get x square plus xy is equal to a square. All right, so now from the similarity of the smaller triangle, the smaller right triangle with the original right triangle, we have this relationship. Now we can also look at this right triangle, which is triangle, let me say ADC. This is similar to the original triangle. Original triangle, so A corresponds to A, but D is the right angle, so that corresponds to C in the original triangle. And C here is the double arc, so that corresponds to B in the original triangle. Now, this time I want to say the ratio of AD over AC. So let's do AD over AC. So first two letters here. AC are the first and third, so I'm going to have first and third here as well. And those of you who know trigonometry, you would say that if I look at the sine of this double arc in this triangle, I get y or AD over AC. Or that should be the same as sine of this angle, because these two are the same. And now we can look at the big original triangle. Then it's going to be sine of this is AC over AB. All right, AD over AC. AD is Y over AC is B is equal to AC is again B over AB. AB is X plus Y. And we can cross multiply again. We get yx or xy, let's write x first, plus y square is equal to b square. Now, from the those two equations, 1 and 2, if you simply add them, when you add them, what you get is a square plus b square on the right. But on the left, notice you have x square plus xy. So let's go ahead and write it down first. X square plus xy plus xy plus y square is equal to a square plus b square. And this quantity, x square plus 2xy plus y square is equal to a square plus b square. But this is nothing but x plus y quantity square is equal to a square plus b square. But x plus y is nothing but c. Notice x plus y is the length AB, which is c. So c square is equal to a square plus b square. And that's the end of the proof.